All right, everyone, buckle up because we are diving deep into the world of human evolution today. I've gone through your research and wow, it looks like we're about to unravel the whole mystery of how we became human. Starting from those very first ancestors millions of years ago and all the way to those things that make us, well, us.
Yeah, it really is like piecing together a puzzle, except the pieces are scattered across like millions of years, hidden in fossils and genes even. We get clues from our primate relatives too.
I love that analogy.
Okay.
Okay, so to solve this puzzle, let's go back to the very beginning. When we talk about evolution, what do we even mean?
So evolution is basically like this ultimate game of adapt or die, right? It's how all living things change over generations, and it's all driven by this thing called natural selection. Okay, imagine a bunch of early humans, right? And some, just by chance, they had slightly better eyesight. Maybe it helped them spot predators quicker or find food easier. You see, those with better eyesight, they were more likely to survive, have kids, and then, bam, those beneficial traits get passed on.
So, like, those small advantages, over time, they added up and shaped the human lineage? It's wild to think about. I mean, we're related to every living thing on Earth, but when we talk about our closest relatives, we're talking chimpanzees and bonobos, right?
Exactly. We share a surprising amount of DNA with them, which is a major clue in our evolutionary story. But to really get the full picture, we got to zoom out a bit. We need to look at this group called hominoids.
Okay, hominoids. So who else is hanging out at this hominoid family reunion?
Well, you've got the gibbons. They're sometimes called the lesser apes because they're a bit smaller. And then there are the great apes, which include the orangutans, those gentle giants from Southeast Asia, the gorillas, those are the powerful but peaceful vegetarians. And then there's the chimpanzees, known for being super smart and having complex social lives. And of course, there's us.
We're the fun ones, right?
Hmm.
But what actually makes hominoids different from all the other primates?
Well, hominoids have some pretty cool things in common that help them do well in tricky environments, and they develop some really complex social structures too. So, first off, compared to other primates, we've got these larger brains, giving us a cognitive edge, and we ditch the tails. This let us have a more upright posture and flexibility. And speaking of flexibility, have you ever noticed our shoulders?
What about them?
They're super flexible, which gave us a greater range of motion, perfect for swinging through trees or, well, I guess eventually inventing the wheel.
It's like the evolutionary version of a multi-tool. Okay, but within this big hominoid family, there's a branch that's extra important to us, the hominins. And this is where things get extra interesting because now we're talking about modern humans and all of our distinct human ancestors.
Absolutely. Hominins are the real stars of our evolutionary show, and two things make them stand out. They walk upright on two legs. We call that bipedal locomotion. And they have even larger brains compared to other primates. And get this amazing lineage started in Africa about 6 to 7 million years ago.
Africa, the cradle of humankind. It's really amazing to think about our ancestors walking around millions of years ago. But as they evolved, those bigger brains and walking upright, those things must have led to some serious changes.
For sure. Over time, hominins went through some major renovations. Their brains got bigger and more complex, which actually changed how they looked. We're talking about changes to the face, like smaller jaws and bigger foreheads. Even the length of their arms and legs changed. Basically, walking upright and getting smarter changed them from head to toe.
So it's like they were trading in their old model for a newer, more sophisticated version. Let's talk about those early hominids, those pioneers who were the first to walk on two legs, like 6 to 8 million years ago.
Now, those guys, they really were the trailblazers of human evolution. They left a legacy. Over a long time, millions of years, different hominid species branched off, and each one had its own little set of adaptations. Of course, some thrived and some died out, but they all played a part in shaping the path that led to us.
It's like they were all part of this grand experiment, testing out different ways of being human. Which leads us to the Australopithecines. Tell me more about these guys.
Oh, the Australopithecines. They were rocking it in Africa between 4.2 and 1.2 million years ago. And let me tell you, there were all kinds of them. Different species adapted to different diets and habitats, from grasslands to forests. They really knew how to make the most of what Africa offered.
This is where our famous friend Lucy comes in. She's like the poster child for Australopithecus afarensis. Her discovery was a big deal for understanding how walking on two legs developed, right?
Absolutely. Lucy is a rock star in the world of paleoanthropology. Our fossils showed us, without a doubt, that Australopithecines were walking upright more than 3 million years ago. But there's a twist. Get this, they also had adaptations for climbing trees. This means they were comfortable in the trees and on the ground.
Wait, so they weren't walking around all day, they were hanging out in the trees too?
Exactly. They were transitioning to walking all the time, but it looks like it was a gradual process. They were adapting to different environments and lifestyles. And speaking of cool ancestors, we can't forget about the Neanderthals.
Oh yes, the
Yeah.
Neanderthals. They're so fascinating. What's the latest on our mysterious relatives?
Well, they were incredibly skilled, that's for sure. I mean, they were master hunters, they took down big animals, and they were amazing tool makers. They made tools out of stone that were super advanced for their time. They even controlled fire. They would have used it for warmth, protection, and probably even cooking, which, let me tell you, was a total game changer. They lived in Europe and Asia from about 400,000 to 40,000 years ago.
They really had it figured out.
Yeah.
But they weren't all brawn, right? They had to have some brains too.
Oh, absolutely. Neanderthals were incredibly sophisticated. We know they buried their dead, which might mean they had complex social customs, maybe even some beliefs about the afterlife. They also made jewelry and even created cave art, which shows they were capable of symbolic thought and expression. And here's the real shocker, get this. Recent genetic studies tell us that Neanderthals actually interbred with early Homo sapiens.
Hold on, wait, are you saying some of us have Neanderthal DNA? Seriously?
Yep. Many people alive today, particularly those with European and Asian ancestry, carry traces of Neanderthal DNA in their genes. It's a pretty amazing reminder that our evolution is intertwined with other hominin species.
Wow. That is incredible. It's amazing to think about. We can't forget about another group who were making their mark back then. The
Yeah.
Cro-Magnons.
Yes, the Cro-Magnons. We often call them early Homo sapiens. And they were making waves in Europe about 45,000 to 18,000 years ago. Like Neanderthals, they were skilled hunters, they used tools and weapons to hunt. But what makes them really stand out is their artistic talent.
Oh, I've always been fascinated by cave paintings. What kind of art did the Cro-Magnons create?
Imagine walking into a cave and boom, these stunning murals of animals, handprints, geometric patterns, all painted with pigments made from natural materials, things like ochre and charcoal. These weren't just doodles either, they were creative expressions, they were telling stories, and maybe even reflecting their spiritual beliefs. But they didn't stop at cave paintings. They also did intricate carvings, they sculpted figures from bone and ivory, and get this, they even created musical instruments.
It sounds like they were the Picassos and Mozarts of their time. They weren't just surviving, they were creating culture.
Exactly. They were developing complex social structures, rituals, beliefs, all the things that form the foundation for what we call civilization.
It's amazing to think that these early humans were capable of all that. We've covered so much in just a few million years, from those first steps on two legs to the incredible culture of the Cro-Magnons.
We've only scratched the surface, and the journey's not over. To understand what truly makes us human, we've got to look closer at those specific adaptations that helped our ancestors not just survive, but actually thrive.
Let's do it. Let's unlock those secrets of our success. Okay, so we've walked in the footsteps of our ancestors, from those early hominids to those culturally sophisticated Cro-Magnons. But what really allowed them to do that? I mean, what sets humans apart from the rest of the primates?
Well, it's kind of like evolution was tinkering, over millions of years, experimenting with different traits. And with humans, these experiments, well, they led to some pretty remarkable adaptations. This unique set of traits is really what allowed us to not just survive, but to truly dominate.
Okay, I'm ready to hear about those evolutionary upgrades. Let's talk about bipedalism again. It seems so basic now, just walking on two legs, but it was a total game changer back then, right?
Oh, completely. Just imagine those early hominids, our ancestors, walking across the African savanna on two legs. This was huge. It wasn't just about standing up straight, it was a whole revolution in movement.
Okay, I'm imagining it. What happened?
Well, think about it. Walking on two legs freed up their hands, so now they can carry food, use tools, even defend themselves, all at the same time.
It's like evolution was prepping them to be the ultimate multitaskers. I can just see them now carrying their latest kill, while they're inventing the first stone tools. But they weren't exactly winning any races back then, right?
Maybe not at first, no, but bipedalism had this surprising advantage. Endurance. It actually let them travel farther using less energy compared to, walking on all fours.
So they became these long-distance travelers. That makes sense, especially if they were following animals or finding new places to live.
That's right. And while their legs were getting them places, their brains, well, those are getting a serious upgrade too.
Our brains are like our secret weapon.
Mhm.
But what was so special about having a larger brain? What did it allow our ancestors to do?
Think of your brain like this incredibly powerful computer, way more powerful than any other primate's brain. And with a bigger brain, that meant more complex thought, better problem solving, more creativity. They could adapt to all kinds of environments, invent new tools, even outsmart predators.
Wow. It's like they were playing chess while everyone else was still figuring out checkers.
And speaking of skills, those opposable thumbs of ours, they're small but mighty, right?
Tell me about it. Those opposable thumbs, along with how agile our hands are, they were key for using tools. That's the precision grip, you know? It allowed them to do all kinds of things with their hands. It's one of the things that really separates us from the apes. I can barely tie my shoes without my thumbs, let alone build a shelter or paint something. But even with those tools and being able to think in new ways, it wouldn't have amounted to much without speech and language.
That's a really good point. Speech and language are really what set us apart from other primates and led to, well, everything that came after. Imagine a world without language. Could we even have this conversation?
It's crazy to even think about. We just take it for granted. We use language for everything. How did that even evolve? How did we learn to talk?
Just picture our ancestors gathered around a fire, sharing stories, figuring out how to survive. Language probably started as a way to communicate more complex ideas, talk about things that happened in the past or might happen later, even plan things together.
It really is like the ultimate social network, connecting our minds instead of, our devices. And to think, it all started with a few sounds and gestures. Okay, so we've got walking upright, big brains, those handy thumbs, and the gift of gab. What else is on the list of amazing human adaptations?
This one might surprise you. Sweat. Doesn't sound that impressive, but those little sweat glands all over our skin, those were essential, especially in that hot African climate where humans first evolved.
Okay, I'll bite. How did sweating help our ancestors?
Well, think about it. Most animals, they overheat really easily, especially if they're running or working hard. But humans, we've got our sweat glands, this amazing cooling system. We could stay cool and keep going, while other animals, well, they just couldn't handle the heat.
So it's like our ancestors had built-in air conditioning. That's amazing. I bet that helped them hunt during the day, travel long distances, and just basically outlast everybody else.
Right. And all of these adaptations, they work together, It's like one big, amazing system. They build upon each other, and it's given humans a real advantage. It's a perfect example of how evolution works. Millions of years of tinkering, refining, to create, well, us, Homo sapiens.
Makes you proud to be a Homo sapiens.
Yeah.
But let's zoom out a bit. What about primate adaptations in general? What are some of the things that have helped primates be successful?
Primates are an incredibly diverse bunch, but they do have some really remarkable things in common. For example, their vision is incredible.
So we're talking bright-eyed primates, seeing the world in HD.
Exactly. Their eyes are at the front of their heads, which gives them something called binocular vision. That means they can see things in 3D. It's how they judge distances so well, and that's crucial for, moving through a complex environment.
It's like they have built-in binoculars. I can barely see what's right in front of me half the time. Okay, but a lot of primates aren't swinging through trees anymore, so why do they still need such good eyesight?
Good question. Even though not all primates live in trees anymore, those sharp eyes, they're still really important. Think about catching a fly or seeing through all the leaves and branches in a forest. Good vision is key for so much of what they do.
That makes sense. And what about those nimble fingers? I've always been amazed by how some primates can peel a banana with their feet.
Oh, yeah. That's thanks to their grasping hands and, of course, those opposable thumbs. That combination gives them a precision grip, and they can manipulate objects with it, whether it's a piece of fruit, a bug, or even a tool.
So opposable thumbs, they really are the ultimate upgrade. From peeling bananas to building tools, these primates have got a handle on success. But let's not forget about those big brains of theirs. We talked about how important they were for humans, but what about other primates?
Well, primates in general have bigger brains compared to their body size than a lot of other mammals. That gives them serious brain power. They've got better cognitive abilities, can solve problems, and can learn.
So they're like the scholars of the mammal world. What are the benefits of having a larger brain for primates?
It really opened up a whole world of possibilities for them. It allowed them to develop these complex social structures, navigate difficult environments, and even come up with new solutions to problems. Chimpanzees, for example, they use tools to crack nuts, sticks to fish for termites. They even use leaves like sponges to soak up water.
Wow. They really are putting those big brains to work.
Huh.
Okay, so we've talked about their incredible vision, those dexterous hands, and their impressive brain power. What about their eating habits? What do primates eat?
Primates are pretty diverse eaters, which is another reason they're so successful. They're not picky. They've adapted to eat all kinds of things, fruits, leaves, insects, seeds, even small animals.
So they're not afraid to try new things. It's amazing how adaptable they are. Yeah. And speaking of adaptations, one thing that always blows my mind is those prehensile tails. Some monkeys, they have tails that are basically like a fifth limb.
Oh, yeah. Those prehensile tails are incredible. You see them mainly in New World monkeys, like spider monkeys, howler monkeys, that kind of thing. Imagine having an extra arm that can hold your entire weight, grab things, and even feel what it's touching.
That's amazing. It's like a built-in grappling hook that can hang from branches, grab food. It's like having an extra hand. I don't know how to coordinate an extra limb, though. But all of these amazing physical adaptations are just one part of it, right? One of the things that make primates stand out is how social they are.
Absolutely. Primates are very social. They live in groups. Sometimes it's just a few individuals, sometimes it's hundreds. These groups help protect them from predators, give them access to more food, and it's how they learn and develop.
It's like living in a busy city. But being around that many other primates, that has to come with some challenges, right?
Oh, for sure. It takes a lot of brain power, good communication, and a whole lot of social skills to navigate those relationships.
So it's not just survival of the fittest, it's survival of the most sociable.
You could say that primates have these really complex social structures. They have hierarchies, alliances, and they rely on all sorts of ways to communicate, to keep things running smoothly.
Okay, so how do they actually communicate? Is it all just grunts and howls?
It's much more sophisticated than that. They use vocalizations, facial expressions, even their posture. All of that communicates what they're thinking and feeling.
That's like they have their own language with its own grammar and everything. Do scientists understand what they're saying?
Scientists are learning more and more about it all the time. They've figured out some of their alarm calls, the ones they use for different predators, calls for when they find food, even ways they show who's dominant or submissive. But we still have a lot to learn about how they talk to each other.
It's like trying to decipher an ancient language. We've covered so much ground, from those adaptations that make humans unique to those things that make all primates so successful. Evolution really is incredible. But where do we go from here? We've talked about the past, but what about the future of human evolution?
That's the million-dollar question.
So we've traveled millions of years, from those first wobbly steps our ancestors took to, well, creating complex cultures and everything. But what happens now? What's next for human evolution? I mean, can we even predict that?
That's the billion-dollar question, isn't it? Predicting the future is tricky, especially with something as complex as evolution. But, we can look around, see what's happening in the world today, and maybe get a sense of how those things might be pushing evolution in a certain direction. And, well, one of the biggest factors now is, well, us.
Okay, yeah, I see what you mean. We've been talking about how the environment shaped us, but now it's like we're the ones shaping the environment. It's kind of a weird thought when you think about it.
It really is. For most of human history, it was all about adapting to whatever the environment threw at us. But now, with all our technology, our impact on the planet, well, we're actually influencing the very forces that drive evolution. Take climate change, for example.
Okay, climate change is a huge problem. We all know that, but how does it play into human evolution?
Well, think about it. Temperatures are rising, weather's getting more extreme. This is going to create all sorts of challenges for us. I mean, we're already seeing it, right? Heat waves, droughts, natural disasters, they're all becoming more frequent. And all of that, it could actually favor adaptations that help us deal with extreme heat, water shortages, even new diseases.
So it's like evolution is being forced to speed up?
Yeah.
That's kind of scary, to be honest, that our actions are actually driving these changes. Are there any other examples, of how we might be shaping our own evolution?
Oh, absolutely. Look at medicine, for instance. We're developing all these treatments for genetic diseases, finding ways to help people have children, even exploring things like gene editing. Those breakthroughs, they could change our gene pool. I mean, we could actually be altering the path of human evolution.
It's like we're taking evolution into our own hands, which is a pretty powerful and maybe even a little bit frightening thought.
It's true. It's a huge responsibility, and it raises all sorts of ethical questions. I mean, on the one hand, we have these incredible opportunities to reduce suffering, improve people's health, but then there's the other side, the unintended consequences. Could we make things worse? Could this increase inequality? These are big questions, and there are no easy answers.
It's a lot to think about. This whole deep dive has really made me look at human evolution in a new way. It's not just about the past, It's still happening. We're a part of it right now.
I couldn't have said it better myself. We're the product of millions of years of evolution, shaped by everything that came before us. And as we continue to evolve, well, We need to use our knowledge, our understanding of this journey to make a better future, not just for ourselves, but for every living thing on this planet.
It's humbling,
Yeah.
and it's a call to action for sure. We've come a long way from those early hominids taking their first steps on the African savanna now. Well, now it's up to us to write the next chapter. That's it for today's deep dive into human evolution. Thanks for listening.